This problem is in static equilibrium. And they're asking us to find the tension. This is a crane, all right? The crane weighs 200 kilograms. We have a tension. This is a rope, and it has a 25-degree angle with the horizontal. All right, learn this one because I'm going to give a lot of problems in future about the static equilibrium. All right, and then the hinge makes a 40-degree angle with the horizontal, and then you were asked to find the tension. So this is because it's in equilibrium, so we have to put the sum of the torques equals 0. And also the sum of the Fx equals 0, and then the sum of Fy equals 0. Like I said, we might like use only the torque, the sum of the torques equals 0, but always put down the three equations. All right, so what torques do we have here? First of all, what forces do we have here?
You have the mg of the crane.
Okay, we have the mg, it's in the middle, always in the center, so it's going to be 9.8 times 200. And tension. All right, so let me calculate that. By the way, this problem is quick. It's like you solve one equation. All right, pay attention, pay attention, pay attention. So, it's 1960 newtons. 1960 newtons. All right. So we only have two forces because this is the hinge, and we're trying to put like the point of rotation at the hinge. All right. The rotation is around the hinge, so we use the hinge as the point of rotation, which means whatever forces we have there, it's not going to cause any torque, so it's not going to be involved. So the force here, they're not going to be involved. So the only thing that's going to be involved in the torque is the T and then the 1960 force. All right, so let's do the 1960 first. So you write 1960, multiply that. What is the perpendicular distance? So if you go down this way, that is the perpendicular distance this way, right? And what is this distance here? That is the tricky point. Is to find the distance that is perpendicular to the line, the line of action of the force. This is the line of action of the force, so we need the perpendicular distance.
15 cosine of 40?
15, you're right, because the whole crane is 30 meters. All right, 30 meters, which means we have 15 here, 15 here, and this is adjacent. This distance perpendicular is a cosine because it's an adjacent. So we have to use 1960, 15 cosine of 40. That is the point where a lot of you are not understanding, is whether to pick cosine or sine. All right? So this is 15 cosine of 40. Guys, for this first here. Now this one here, we're gonna go line of action. So this is the line of action, and it's gonna be perpendicular to the hinge. So it's gonna be this way. So we have a 90-degree angle here. All right, so this is my distance. This is my distance. All right? Dueñas, pay attention. This is the distance that we want. All right? And next time, I'm not gonna help nobody, okay? You need to know this yourself. This is the distance that we need. We have an angle of 15, so we have to use sine. And I'm calling this clockwise because it's going this way. So this is gonna be counterclockwise, which means it's gonna be minus. If I'm calling clockwise positive, it's gonna have positive torque. That means the tension is gonna go the opposite way as counterclockwise, we're gonna use negative. So minus T, right? This one is quick. It takes like one equation to solve it. All right, so minus T. Now, what is this distance that is perpendicular to the pivot? Do you use 15 or do you use 30? What else do you use? So the force times the distance. but the distance is going to be 30 sine 15. All right, now where does that 15 come from, by the way? How do we get the 15 here? Now I put that in, but it's not so obvious. How do you get the
Geometry. You just add each angle because each one's a triangle, so it's gonna add up to 180 degrees, and eventually you're gonna.
Exactly. That's the problem that you helped me last time. Okay, we have 25 here, and this is a triangle, right? You have an angle here. That's 25. You subtract the because you have 40, so that's 140.
And the total of that line is 180.
All right, and the whole thing is 180. So 140 plus 25 is 165, and then you subtract that from 180, you get 15. All right, so you have that's how you have a 15 degrees there. Now, so the opposite side that we're going to use as a distance is perpendicular, so we have to use sine. So it's minus t 30 sine of 15. And then you make that equal. That's it. The physics is done. The physics is done. Now it's the algebra. There is one equation. When you write the equations, I mean, you're done with the physics. The rest is just algebra. Now you solve that for t. It's one equation, one variable. Sine 15, you can look it up. Cosine 40, you can put it in the calculator. And if you don't solve, if you know how to solve this equation, then I don't know what to say. So t is going to be, if you solve that, it's going to be 2902.3. 2902.3 Newton. Again, you find sine 15 in the calculator, you multiply by 30, you find cosine 40 in the calculator, multiply by 15, arrange the equation, solve for t, you get the answer. All right, that's it.